So my job is to say which one looks worse than the other, and I'm like, they're both wicked in my world. And then I say, ooh, I can factor both sides. This is the difference of squares. This has a common factor. So I'm going to pick. I picked this, and I factored the difference of squares. We did this yesterday. The square root of the fourth power is 2, and then square root of 1 is 1. Don't start writing this down. Okay? Then I said, ooh, look, that's a Pythagorean identity. That is cosecant squared, right? Ooh, I need those. True? So progress has been made. At this point, I chose to go, I'm like, oh, well, look, it's out here by itself and these aren't, but look, I can pull it out. So I'm keeping my end in sight, and I'm like, oh, let's just go ahead and pull out on this side. See how I switched sides, and I totally can tell I switched sides? And I factored it out. At this point, I haven't got anything else. I can say these are both cosecants. These are not. Do I know a Pythagorean identity that can get rid of cotan and get me a cosecant? Isn't 1 plus cotan squared equal cosecant squared? So I have 1 plus cotan squared equals cosecant squared, but I want to plug in for cotan, true? Oh, I'm sorry, can we good? So cotan squared is equal to cosecant minus 1. Do we agree? So over here, I'm going back to this side. I'm going to be like 1 minus, I want this now. So I put, instead of this, I put that. I'm just bringing the cosecant along for the ride. I'm going to distribute the negative. Oh, by golly, look, I'm going to have a negative something. And I'm going to have a 1 plus 1. Oop, that's a 2 something. True? So I'm going to distribute the negative and combine like terms. And because I need it to be exactly the same, I'm going to leave one side the way I want it, and I'm going to flip the order of this side. And again, somebody else may be able to do it in smaller steps or less steps, but this is the way I saw it. It's a factoring one.